If we don't get John to come and see Hong Kong. So John, this has been assembled at short notice. We have a collection of UCL alum, UCL Alumni Association board members, 2 students who are about to go to UCL tomorrow, and a few potential UCL candidates. And please tell us a little bit about what you do and your impression about the state of the physics world, both in your horizon as well as in China.
Okay, so thank you. Oh, well, thanks for all turning out on a Sunday. It's Sunday, isn't it? Monday. It's been a busy week. Thanks for all turning out on a Monday afternoon to hear about physics and to meet me. It's really nice to meet you all. Really, I'm very privileged that Dix has been hosting me this week. We work together on council a lot, and it's really nice to see. Now when you're on the Zoom call, I have some idea where you are, which will be really good.
Actually, you can join me tomorrow. The governance committee.
Oh, no, I'm not. Let's discuss that. A little bit about what physics is about, first of all. Some of you this will be old news, so we'll get to the cutting edge at some point. But physics is really about trying to explain the most things with the fewest laws. That's the approach. Which is not always the best approach. If you're a biologist, that's just people go, that's not the way to do it because everything's different. But nevertheless, even in biology, there are actually some underlying laws you can learn. The underlying physics of biology is actually something that can tell you something. One of the things I did when I was head of department at UCL was actually found the biological physics group, because I think there are things that we can learn from each other in both directions, from biology and physics. If you like, the most reductionist approach to physics is really, let's look at the universe as closely as we can and see what it's made of. And then the way I kind of think of it is, you take any piece of material, a piece of the air or a piece of the chair or whatever, and you cut it in half, and you cut it in half again, cut it in half again. Keep doing that. And the question we're really trying to address in particle physics is, does that process ever stop? Can you keep cutting it in half over and over and over again, smaller? Or does it stop? And if it stops, does it stop with the same constituents wherever you started from? You start with a neutron star, you start with a carpet, you start with a fingernail, wherever it might be. And we have an answer to that question at the moment. Like all answers in science, it's kind of provisional, in that it's our best model so far of the way the universe works. But it's called the Standard Model. And it tells you that you end up with electrons, for instance, you're probably most familiar with the line particle. There are 2 other particles like the electron we were just discussing, the tau and the muon. And then quarks. So the proton, for instance, inside the atomic nucleus is not fundamental, it has quarks. The Standard Model, well, it's a fantastic theory, and it predicted the Higgs, and it predicts all kinds of phenomena. It's very elegant, very economic. It's not a theory of everything, it's not the end of physics, there's a lot more to it.